In the high-stakes world of technology, a new power is emerging. China, once known for manufacturing, is now rapidly becoming a leader in cutting-edge research, particularly in the field of semiconductors. These tiny chips are the brains of our modern world, powering everything from smartphones to supercomputers. Recent headlines tell the story, "China overtakes us in semiconductor research output, and Chinese universities top global rankings in chip design." These are not isolated incidents. A recent report by the Australian Strategic Policy Institute revealed that China has surpassed the United States in 37 out of 44 critical technologies, including advanced chip design and production. This shift in the technological landscape is being driven by China's universities, which are attracting top talent and producing groundbreaking research at an unprecedented rate. From Shanghai to Shenzhen, Chinese universities are becoming hotbeds of innovation, challenging the traditional dominance of American and European institutions. This surge in Chinese research prowess is not a coincidence. It is the result of a deliberate decades-long strategy by the Chinese government to invest heavily in education, research and development, with a particular focus on semiconductors. This strategic focus is positioning China to become the world's leading technological superpower, with far-reaching implications for the global economy and the balance of power. Semiconductors, often referred to as microchips or simply chips, are the unsung heroes of the digital age. These tiny components, often smaller than a fingernail, are the brains behind our electronic devices. They process and store information, enabling the complex calculations and operations that power our smartphones, computers, cars, and countless other devices. The importance of semiconductors extends far beyond consumer electronics. They are crucial for national security, powering advanced military equipment, communication systems, and critical infrastructure. In an increasingly digital world, semiconductors are the foundation upon which economic prosperity and national security are built. Imagine a world without semiconductors. There would be no smartphones, no laptops, no internet as we know it. Cars would lack advanced safety features and medical equipment would be significantly less sophisticated. The global economy, heavily reliant on digital technologies, would grind to a halt. The COVID-19 pandemic highlighted the critical importance of semiconductors. As global lockdowns spurred demand for electronic devices and disrupted supply chains, the world experienced a severe chip shortage. This shortage impacted industries worldwide, from automotive manufacturing to consumer electronics, underscoring the vulnerability of global supply chains and the strategic importance of semiconductor production. The rise of China's universities in semiconductor research is not anecdotal, it's backed by hard data. A recent study published in the journal Nature analyzed research publications in semiconductor technologies over the past decade. The findings were striking. Chinese researchers now publish the highest number of scientific papers related to chip design and manufacturing. Not only that, but the quality of their research, as measured by citations in other scientific papers, has also skyrocketed. In some specialized areas like the development of next-generation transistors, Chinese universities are now leading the world in both the quantity and impact of their research output. This academic surge is translating into real-world results. Chinese companies like Huawei and SMIC have emerged as major players in the global semiconductor industry, challenging established giants like Intel and Samsung. Huawei in particular made headlines for its advanced chip designs before facing trade restrictions imposed by the United States. These achievements are a testament to the effectiveness of China's strategic investment in education and research. By pouring resources into its universities, fostering collaboration between academia and industry, and setting ambitious national goals, China has created a fertile ecosystem for semiconductor innovation. China's rise in semiconductor research is not a matter of chance. It's the result of a carefully crafted strategy. Recognizing the strategic importance of semiconductors, the Chinese government embarked on a multi-decade plan to achieve self-sufficiency and global leadership in this critical technology. At the heart of this strategy is a focus on education and research. The Chinese government has poured billions of dollars into its universities, establishing state-of-the-art research facilities, attracting leading scientists from around the world, and cultivating a new generation of highly skilled engineers. Central to this effort has been the creation of specialized universities dedicated to microelectronics. These institutions, modeled after MIT and other leading engineering schools, provide students with a world-class education and unparalleled research opportunities in semiconductor technologies. Beyond funding, China has fostered a culture of collaboration between academia and industry. Universities are encouraged to partner with companies, ensuring that research translates into practical applications and commercial products. This close relationship between research and development has accelerated the pace of innovation and helped Chinese companies quickly adopt cutting-edge technologies. The Chinese government's strategic vision, coupled with sustained investment and a focus on collaboration, has created a formidable innovation ecosystem that is propelling China towards semiconductor dominance. The United States, long a leader in semiconductor technology, has responded to China's rise with the CHIPS and Science Act. Passed in 2022, the act provides billions for research, domestic chip production, and workforce development. Yet critics say funding may not close the gap with China, and a shortage of skilled workers remains a challenge. Experts call for a broader national strategy, aligning research, industry, and education to secure U.S. leadership in semiconductors. The competition between China and the United States in semiconductors is about more than just technological superiority. It has far-reaching geopolitical implications. Some analysts describe it as a new tech Cold War, with both countries vying for control of a technology that underpins economic and military power. This rivalry is already reshaping the global landscape. Countries around the world are being forced to choose sides, aligning themselves with either the United States or China in terms of trade, technology, and investment. This division is creating new alliances and exacerbating existing tensions, adding complexity to an already volatile geopolitical environment. The chip race is also fueling a global scramble for talent. China is aggressively recruiting top engineers and scientists from around the world, offering lucrative salaries and access to cutting-edge research facilities. The United States, in response, is implementing policies to attract and retain top talent, recognizing that brainpower is the new battleground in the 21st century. The outcome of this tech Cold War will have profound consequences for the global balance of power, shaping the future of innovation, economic prosperity, and international security. The race for semiconductor supremacy is not a zero-sum game. While China and the US lead, the ripple effects are global. Countries worldwide are investing in semiconductor R&D, recognizing its strategic importance. This competition is accelerating innovation, driving the development of smaller, faster, and more efficient chips. But geopolitical rivalries risk fragmenting the industry, causing supply chain disruptions and higher costs. Cooperation and open markets are crucial for continued progress in this vital technology. The race for semiconductor supremacy is about much more than just chips. It's about the future of technology, economic prosperity, and global power. Whoever controls this critical technology will have a significant advantage in the years to come. Semiconductors are the foundation upon which the digital economy is built. They power the artificial intelligence, cloud computing, and big data technologies that are transforming industries and societies worldwide. Dominance in semiconductors translates into dominance in these emerging technologies, giving countries a competitive edge in the global marketplace. Moreover, semiconductors are essential for national security. They power the advanced weapons systems, communication networks, and intelligence-gathering capabilities that are crucial for military superiority in the 21st century. A country that relies on foreign suppliers for its semiconductors is vulnerable to supply chain disruptions, technological espionage, and even economic coercion. The stakes in the semiconductor race are incredibly high. The outcome will determine the shape of the global order, influence the balance of power, and shape the technological landscape for decades to come. The semiconductor race is dynamic and rapidly evolving. AI, quantum computing, and supply chain resilience are shaping the future. AI demands powerful chips, while quantum computers push the limits of semiconductor technology. The pandemic exposed supply chain fragility, driving countries to diversify and restructure. Talent wars are heating up. Those who attract top minds will lead. The race is a marathon, not a sprint, and the finish line keeps moving.